Thakur Vidya Mandir High School and Junior College welcomes all the 12th standard computer science students. Today, we are going to learn a new part in Unit 1, that is Introduction to 8085 Microprocessor and its organization. We are going to learn about the pin configuration of 8085 microprocessor. So here you can see I have shown you the IC of 8085 microprocessor. Regarding an IC, how it looks like, already we have discussed in logic gates. So IC are fabricated using our active and passive components. ICs are fabricated using active and passive components. After the invention of the semiconductor technology, the ICs are invented which reduces the size of the circuit that we are going to use. So my microprocessor IC will be manufactured using many active and passive components. The ICs, after the invention of advanced technology, the IC that was invented always belongs to the unipolar family. Now, what is a unipolar family? It is nothing. Students, when we have learned about transistors, we said that transistors are classified into two parts, bipolar transistor and unipolar transistor. Unipolar transistor means, or we can say unipolar family means the transistor action will take place due to only one charge carrier. That will be always the majority charge carrier. So the ICs are manufactured using unipolar technology. They comes under the family of unipolar. So keep in mind all the microprocessor IC, not the logic gate IC, all the microprocessor IC. So this is the pin configuration of 8085 microprocessor. So you can see here students, the microprocessor has a 40 pin. So the 40 pin are placed in a DIP, that is dual inline package. Now what is dual inline package? It is an electronic component package with a rectangular housing and two parallel rows of electrical connecting pins. Again I am repeating, it is an electronic component package with a rectangular housing and two parallel rows of electrical connecting pins. This is how the pins are arranged in DIP. So if it is a 40 pin IC, 2020 it has been equally bifurcated and it is arranged in DIP. When you look into the pin configuration students, some of the pins already we have discussed about in our earlier class. So we are going to learn about the function of each and every pin in detail. So this is the functional pin diagram. The first diagram is similar to the previous one that I have showed you. The second diagram, the 40 pin is further classified into different parts, or we can say different categories, depending upon the type of depending upon the operation, or we can say depending upon the users. So this is the functional view. The second diagram that you can see here, it is the functional view of 8085. This is the pin configuration of 8085. Now each and every IC first has a notch. It is arranged in a rectangular DIP, dual inline package. It has a notch. Regarding the notch, already we have discussed, because notch plays a very important role. With the help of the notch, we will able to identify from where the number of the IC starts, because when we take an IC, we will never come to know from where the pin number starts. So the pin of the IC, that is from where the number is going to start, we will be able to identify with the help of the notch. Already we have discussed this in logic gates, 11th standard, how to identify the notch and from where the number is going to start. So you can see here 8085 microprocessor, these are my 40 pins. Now the 40 pins are classified into different parts, different categories depending upon the working. So we are going to discuss about the working of each and every pin. So firstly, let us learn about the different categories. Firstly, we have the power supply, clock signals. Secondly, thirdly, we have the multiplexed address and data bus. We have the higher order address bus, serial in output signals, interrupt signals, control and status signals, externally initiated signals, and lastly we have the DMA signals. From this, students, some of the concept you can see, that is the multiplexed address and data bus, interrupts, higher order address bus. All this we have discussed in our previous class. Now let us discuss about each and every function of this analysis. So firstly, the power supply. As we know, each and every IC requires power supply for the operation. The microprocessor will be requiring plus 5 volt DC power supply for its operation. The microprocessor will be requiring plus 5 volt DC power supply for the operation. So here, if I am giving a power supply, it has two terminals, a positive and a negative. The positive terminal is given to pin number 40, that is VCC, and the negative terminal is pin number 20, VSS, which is grounded. Okay, so each and every IC require power supply for the operation. A microprocessor will be requiring plus 5 volt DC power supply, where the positive terminal of the battery is given to pin number 40 and the negative terminal is given to pin number 20, which is grounded. So this is the first concept part, that is power supply. We are going to discuss about the clock signals. So here we can see again the IC885 microprocessor with the notch, pin number 1 and 2. Now pin number 1 and 2 is connected to a crystal. Pin number 1 and 2 is used to provide clock signals for the operation. Now what are clock signals? Clock signals are nothing, they play a very important role to drive the internal circuitry. With the help of the clock signals, we will be able to drive the internal circuitry. So here you can see X1 and X2 clock signals. You can see here the second diagram. Across X1 and X2, this is the symbol of your crystal. A crystal is connected, okay, and pin number 40 is plus VCC and ground is 20. This we have already discussed. So across pin number X1 and X2, we are going to connect a crystal. Why we use a crystal? The crystal is used to provide proper frequency for the operation. The crystal is used to drive the internal circuitry. Okay, so now let us discuss about pin X1 and X2. This is the X1 and X2. X1 and X2 are connected to an external crystal with the help of RC or LC network, which drives an internal circuitry of the microprocessor. Now X1 and X2 across, we are going to connect a crystal with the help of RC. RC is nothing, resistance capacitance, or LC. LC is nothing, inductance capacitance. In most of the processors that we can see, it will be always RC, resistance capacitance, which is used to drive the internal circuitry of the microprocessor. The crystal is always used to provide suitable clock for the operation. The frequency is internally divided by 2. So when I am connecting a crystal across pin number X1 and X2, the frequency will be internally divided by 2. That is across X1 and X2. So that crystal that I am going to take should be always twice the operating frequency. The operating frequency range of 80-85 is minimum 500 kHz and maximum it is 3 MHz. The crystal frequency is 6 MHz. As I said, the crystal frequency will be always twice the operating frequency. So when I am connecting a 6 MHz crystal across pin number X1 and X2, the 6 MHz frequency will be internally divided by 2 and it goes across pin number X1 and X2 as 3 MHz and 3 MHz. This crystal, which is placed outside the processor, will be driving the internal circuitry. The internal circuitry might be the oscillator, and the oscillator will be again used to drive the timing and control unit. So let us discuss about this in the next slide. So this is how a crystal looks like. So use of a crystal. This is my timing and control unit. The timing and control unit, you know, it will be always providing proper frequency timing for the operation that is going to take place. and the timing and the control unit output is always connected to the processor for performing any operation. Now, the oscillator we are going to use in order to drive the timing and the control unit. So the output of the oscillator is always given to the timing and the control unit. What is an oscillator? Oscillator is nothing. It will be a type of amplifier which will be working on feedback. It is a type of amplifier. It consists of an amplifier, or we can say it is a type of amplifier which works on feedback. Now, what is a feedback? A part of the output portion when I am giving again as to the input, that is called as feedback. Again, I am saying the part of the output when I am giving again to the input, that is called as a feedback. Feedback is more important in oscillators because via the feedback circuit, we will be able to decide what is the perfect clock frequency that we require. Okay, so the oscillator. So here the feedback is given with the help of RC and LC network. That is why outside the crystal we are having the RC and LC. So RC and LC network will help the oscillator to give your feedback. And this is my crystal. So the crystal, that is 6 megahertz, will be driving the internal circuitry. Now here the internal circuit is nothing but your oscillator. So again I am repeating the concept of crystal. A crystal of particular frequency is connected across pin number X1 and X2. The crystal is used to provide proper frequency for the operation. The crystal is internally divided by 2. That is why the crystal frequency. That is why the crystal that we are going to operate should be always twice the operating frequency. So the operating frequency will be ranging from 500 kilohertz to 3 megahertz. 500 will be the minimum and 3 megahertz will be the maximum. 8085 microprocessor circuit will be using a 6 megahertz crystal. So how much is the crystal frequency? It is 6 megahertz. And the operating frequency of 8085 microprocessor is 3 megahertz. The internal circuitry consists of an oscillator. The oscillator is nothing, it is an amplifier, okay, which is having an amplifier and a feedback circuit. The feedback circuit of an oscillator can be RC or LC type that I have discussed in the previous slide. The feedback circuit always decides the frequency of the signal generated by the oscillator. So the feedback circuit is very, very important. We are not able to place the feedback circuit internally inside the oscillator. That is why we keep it externally. So when we see the microprocessor circuit along with the crystal, we can see there will be always a resistance, that will be carbon composition resistor and a ceramic capacitor. Next, clock signal. Let us discuss about clock out. Clock out or X1, X2 already we have learned clock out, which is occupied by pin number 37. The clock out signal. Clock out. The whole circuitry is synchronized with clock. We know the processor, with the help of the timing and the control unit, it performs all the operations. So the entire processor is synchronized with clock. The speed of the system depends upon the clock frequency. Clock out is nothing. It is a system clock for devices, that is peripherals, which is connected with the processor. So it is present inside the processor and it is used by the peripherals for any operation to be performed. The clock out frequency will be always half the crystal frequency. So the crystal frequency is 6 megahertz and the clock out frequency will be always half of it, that is 3 megahertz. So this is how we learned about the clock out. So by this, X1 and X2 and clock out together forms your clock signals. Next, let us discuss about the multiplexed address and data bus. From pin number 12 to pin number 19 is occupied by the multiplexed address and data bus, that is AD0 to AD7. We have already discussed about the multiplexed address and data bus in detail in our previous class. So now let AD0 to AD7. It is the multiplex address and data bus. The signal lines AD0 to AD7 are bidirectional. We know that it consists of your lower order address bus as well as the data bus. Address bus is unidirectional, data bus is bidirectional. We are going to share the 7 lines common for address and data bus. So we take it as bidirectional because data is also there. They are used for dual purpose. So what is the dual purpose? They are used as lower order address bus as well as data bus. While executing an instruction, whenever any process is taking place during the earlier part of the cycle, these lines are treated as lower order address bus. Later on, they will be treated as the data bus. So whenever a program starts, whenever the fetching operation is taking place, the processor will be using it as the lower order address bus. Later on, it will be using it as the data bus. However, the lower order address bus can be separated from these signals using latch. Latch is nothing but your ALE. Next, let us discuss about the higher order address bus. From 21 to 28, it is occupied by the higher order address bus. So, we know our microprocessor has 16 address lines. The most significant bit A8 to A15 of address bus is separate. The least significant bit A0 to A7 are time multiplexed with a bidirectional data bus, that is D0 to D7. The 8 lines A8 to A15 which are unidirectional and are used as higher order address bus. So students, here we have 16 address lines, we have 8 data lines. The 16 address lines are further classified as A0 to A7, which is the lower order address bus, and A8 to A15, which is the higher order address bus, in order to reduce the number of lines, the pins. The lower order address bus is multiplexed with a data bus to form AD0 to AD7. The higher order is always kept separate. Address bus is always unidirectional. Multiplexed address and data bus, because of the data, it becomes bidirectional. Higher order address bus, again it will be unidirectional. So in today's class, we have discussed about the few pins of 8085 microprocessor, starting with the clock signals, multiplexed address and data bus, power supply, and higher order address bus. So how much power supply the processor requires for the operation? Is just plus 5 volt DC power supply, which is given to pin number 40 and grounded at pin number 20. Clock signal. The crystal frequency is 6 megahertz and the clock frequency is and the operating frequency is 3 megahertz. Crystal and operating frequency, it can be asked in fill-ups. So crystal is connected to provide proper frequency for the operation. Clock out signal. It is a system clock present inside the processor but is used by the peripherals for operation. Clock out will be always half the crystal frequency, that is 3 megahertz. Next, multiplexed address and data bus. AD0 to AD7, that is pin number 12 to 19, is occupied by the multiplexed address and data bus. They are used both as a lower order address bus as well as a data bus. Lastly, we have the higher order address bus. So from pin number 21 to 28 is occupied by the higher order address bus. They are unidirectional. They are always kept separate because lower order is multiplexed in order to reduce the number of pins. So only this concept we have discussed about today in today's class. In next class, we will learn the remaining pins of pin 8085 in detail. Thank you.